Hello and welcome to another session of Learning Mathematics. I am Shikha Gautam and today I will help you to learn some sections of your first chapter sets of class 11th mathematics book. Set theory was developed by a German mathematician Georg Cantor. Set plays a very vital role in present-day mathematics. It is commonly used in geometry, sequences, probability and many such branches of mathematics. In this session, we are going to learn about various kinds of sets, Venn diagrams and operation on sets. Coming to the first topic, various kinds of sets. If I ask you to consider the set of even prime numbers, you will all know that this set contains the element 2. But what if I ask you to consider the set of even prime numbers which are greater than 2? You will know that this set does not contain any element. So such sets which do not contain any element are called empty sets. They can also be called null sets or void sets. These sets are represented by the symbol phi or with empty braces. You can think of many more such examples of empty sets. Let me give you one such example. Consider the set A having the elements x such that x lies between 1 and 2 where x is a natural number. Now you will see that this set is an empty set because there is no natural number between 1 and 2. Now let us take another example. Let A be a set of weekdays and B be a set of points on a line. Then set A has 7 elements in it. Therefore, it will be called a finite set. Whereas set B has infinite elements in it because we all know that there are infinite points on a line. So set B is called an infinite set. If we take another set A consisting of elements x such that x is less than 5 where x is a natural number, then set A will have the elements 1, 2, 3 and 4. Thus, this set is a finite set. But if B is a set of elements x such that x is a natural number, then this set B will have the elements 1, 2, 3, 4, 5 and this will go on endlessly. Thus, B is called an infinite set. So, we can say that an empty set or a set that contains finite number of elements is called a finite set, otherwise it is called an infinite set. Two more sets. Let A be a set of elements 1, 2, 3 and 4 and let B be another set of elements 3, 1, 2, 4. Then we can closely observe and see that all the elements of set A are also elements of set B and that all the elements of set B are also elements of set A. Such sets are said to be equal sets and it is denoted by A equal to B. If these sets had not been equal, they would have been given by the notation A not equal to B. Let us take another example. Let set A have the elements 1 and 2 and set B have the elements 1, 1, 2, 2, 2. Again, we can see that all the elements of set A are elements of set B also and all the elements of set B are also elements of set A. Thus, we can say that set A is equal to set B. So, it is noteworthy here that even if one or more elements are repeated, the set does not change its identity. So, in this section, we learnt about empty sets, finite and infinite sets and equal sets. In the next part, we are going to discuss about Venn diagrams. Now, the relationship between the various sets can be represented with the help of Venn diagrams. But what are Venn diagrams? Venn diagrams consist of rectangles and closed curves which are usually circles. All the elements of the set are written within these closed curves. The universal set is denoted by the rectangle and its subsets are denoted by the circle. For example, let U be the universal set containing the elements 1, 2, 3, 4 and 5. And let A be its subset containing the elements 2, and 4. Then the Venn diagram will be represented like this. The universal set will be denoted by the rectangle and its subset A will be represented by the circle. The elements of set A will be written inside the circle. Since A has the elements 2 and 4, the numbers 2 and 4 will be written inside set A. And the remaining elements 1, 3 and 5 will be written inside the rectangle. These Venn diagrams will be extensively used when we discuss the operations on sets. As we all know that when we perform the operations of addition, subtraction, multiplication and division on numbers, we get a new number. Similarly, if we perform certain operations on sets, we get a new set. In this topic, we are going to define certain operations on sets and examine their various properties. The first operation on set is the union of sets. Let A and B be two sets. Then the union of these sets A and B will be the set containing all the elements of set A and all the elements of set B, taking the common elements only once. Union is represented by this symbol and it is written as A union B. Let me explain the union of sets in detail, taking the help of an example. Let A be a set containing the elements 1, 2, 3 and 4 and B be a set containing the elements 2, 4, 6 and 8. Then A union B will be the set containing all the elements of set A and all the elements of set B, taking the common elements only once. That is, the set contains the elements 1, 2, 3, 4, 6 and 8. Mathematically, we write it as A union B will be the set of elements X such that X belong to A or X belong to B. With the help of Venn diagram, it will be represented like this. The rectangle represents the universal set and A and B, the sets are represented in circles inside the rectangle. The shaded portion will give us A union B. Now let us examine some properties of union of sets. The first property is the commutative law, which states that A union B is equal to B union A. The second property, associative law, states that A union B union C is same as A union B union C. These two properties can be easily verified with the help of some examples. The third property is the law of identity elements, which states that the union of a set with a null set is the set itself. That is, A union phi gives us the set A. The fourth property is the idempotent law, which states that the union of any set with itself gives us the same set. That is, A union A gives us the set A. The last property is the law of universal set, which says that the union of a universal set with any set is the universal set itself. That is, U union A gives us U. We can also conclude here that if A is contained in B, that is, if A is a subset of set B, then the union of A and B will give us B. That means the union of a subset and the superset will give us a superset. We have just studied about the union of sets. Let us now discuss the next operation, which is the intersection of sets. Let A and B be any two sets. Then the intersection of set A and B will be the set which contains the elements which are common to both A and B. Intersection is represented by this symbol and it is written as A intersection B. Let me explain you intersection in detail with the help of an example. Let A be a set containing the elements 1, 2, 3 and 4 and B be another set which has elements 2, 4, 6 and 8. Then A intersection B will be the set which contain the elements which are common to both A and B. That is, A intersection B will contain the elements 2 and 4. Mathematically, we write it as A intersection B is the set of elements X such that X belong to A and X belong to B. With the help of Venn diagram, it can be represented like this. Here, the shaded portion will represent A intersection B. Now, let us discuss some properties of intersection of sets. As we discussed in the union of sets, the first property here also states that A intersection B will be same as B intersection A. This is called the commutative law. The second law is the associative law, which states that A intersection B intersection C will be same as A intersection B intersection C. These two laws can be easily verified with the help of some examples. The third law is the law of null set, which states that the intersection of any set with a null set will give us a null set, or phi intersection A gives us phi. The fourth law is the idempotent law, which states that the intersection of any set with itself gives the set itself. That is, A intersection A gives us the set A. The next law is the law of universal set, which says that the intersection of any set with a universal set will give us the set itself. That is, universal set intersection A gives us set A. We can further conclude that if A is contained in B, that is, A is a subset of the set B, then A intersection B will give us A. So, if we intersect a subset with a superset, then the intersection will give us the subset. Another important law is the distributive law, which states that A intersection B union C can be written as A intersection B union A intersection C. That is, intersection distributes over union and vice versa. We can prove this distributive law with the help of Venn diagrams. If we consider the LHS of the distributive law, it contains A intersection B union C. If we draw the Venn diagram of B union C, it will look like this. Here, this shaded part will represent B union C. Now, if I intersect this B union C with the set A, this shaded part will represent A intersection B union C. Now, coming to the right hand side of the distributive law, we have that A intersection B union A intersection C. Drawing the Venn diagram of A intersection B, we can see that this shaded part represents A intersection B. Drawing the Venn diagram of A intersection C, we can see that this shaded part is represented as A intersection C. But when I do the union of both these Venn diagrams, I will get A intersection B union A intersection C. And the Venn diagram will be represented like this. This shaded region represents my right hand side. Now we can see that the left hand side and the right hand side of the distributive law is verified with the help of the Venn diagrams. Another important property of intersection of sets is for disjoint sets. But what are disjoint sets? Consider an example. Let set A be the set of elements consisting 2, 4 and 6, and set B contain the elements 1, 3 and 5. If I do the intersection of set A and B, we know that the intersection of these sets will be the sets which have the common elements of both the set. But here we can observe that set A and set B do not have any common element. So, mathematically we can say that A intersection B is phi. Such sets in which the intersection of two sets comes out to be a null set are called disjoint sets. Diagrammatically, it can be represented like this. We have just finished discussing the operation of sets, which was intersection. Let us now come to the third operation, which is the difference of sets. the difference of two sets A and B in the same order, which is very important, is denoted by A minus B. A minus B is the set which contains the elements which belong only to A but not to B. With the Venn diagram, we can clearly see the difference of sets. The Venn diagram for A minus B is represented like this. Here, the shaded portion gives us A minus B, that is, all the elements that belong to only A. That is, all the elements belonging to A but not to B. Similarly, the difference of two sets B and A in the same order is given as B minus A. So, B minus A will be the set of elements which contains the elements of only B but not A. With the help of Venn diagram, it will be represented like this. This shaded portion represents B minus A, that is, the elements which belong to only B. That is, the elements which are a part of set B but not part of set A. Let us discuss the difference of sets in detail with the help of some examples. Let A be a set containing the elements 1, 2, 3, 4, 5, 6, and let B be another set containing the elements 2, 4, 6 and 8. Then the difference of set, that is A minus B, will be the elements of A that do not belong to B. Therefore, A minus B will be the set containing the elements 1, 3 and 5. B minus A, that is, the difference of B and A, that is B minus A, will be the set of elements which belong to only B but not A. And we can see that B minus A will be the set of element 8. It is noteworthy here that A minus B does not come out to be equal to B minus A. Mathematically, we write A minus B as the set of elements X such that X belongs to A and X does not belong to B. Similarly, B minus A will be the set of elements X such that X does not belong to A and X belongs to B. Let us now conclude this session by recapitulating the important points that we had discussed. In this session, we had discussed about the various kinds of sets, which were empty sets, finite and infinite sets, and equal sets. Then we learnt about Venn diagrams and operation on sets. The operations that we discussed were union, intersection, and difference of sets. Students, in the next session, we will discuss about the complement of a set and some practical problems on union and intersection of sets.